Okay, thank you all for coming today, for staying there and spend some time with EMITE in this webinar. We are going to do a demonstration of one of our new external modules, which is capable of testing access points. At the same time, you can test devices. It can work as a station, and also it can work as a external AP. Okay, so this is the new functionality that we have developed. This is the box. We call it external AP module. This box can work with almost all the WLAN technologies, ranging from Wi-Fi A, B, G, N, AC, and finally Wi-Fi 6, which is Wi-Fi AX. As you can see, this box has 4 RF filters, so we can test up to 4x4. But the technology Wi-Fi 6 can use up to 8 antennas, I think. But so far we only have 4 ports. The chamber, the box, also has this Ethernet filter, which is used by the software to control the AP which is inside, and also this cable is used to transmit the data, the FTP, UDP, video streaming data from the control PC to the device that we want to test. And here also has the switch, the power switch, and finally the power cord. Okay? And we are going to do in this webinar, we are going to test an AP. We are going to test the performance of an AP working in WLAN AX, and also we are going to test the behavior of a device. In this case, this is a Samsung S10. We are going to test it using Wi-Fi 6, Wi-Fi AX. Okay, so I think we can get started with the connection setup that we need for testing an access point. Okay, you can have a look inside. Inside, you can see we have already the access point that we are going to test. It's an Wi-Fi 6 capable access point. This access point, of course, needs to be power supplied, and it has to be managed externally using another PC, which is this PC. We call this auxiliary PC or AP PC. Okay, through this computer we can access the AP under test and configure the channel, the bandwidth, and the technology that we want to test. Okay? For connecting this PC to the AP, the chamber is provided with an Ethernet filter that you can see there. Okay? And finally, the Ethernet cable goes to this PC. Okay? So let's get started from the beginning. I think you can see the auxiliary PC. Okay, this is the web browser that controls the AP that we want to test. In wireless, I need to enter. In wireless menu, you can configure the band. We are going to use 5 gigahertz. You can configure the technology to be used, and also the bandwidth and the channel. We are going to be testing the 44 channel. So click apply. Okay. Now for testing, this computer has to be running the MIMO client software. So let's open it. So I think you can see it there, the client. And you can read here the AP, okay? The AP that this PC is using. All right? And also in the web browser, you can read the SSID, which is Access Test AX. Okay, now let's go to the software, which is already open. Okay, for testing, we are going to go to time domain, WLAN. And as you can see, the software is telling you how the cables are needed to be connected. Okay? In this case, we are using 4 antennas. So the cables are connected to WLAN TRX ports. Okay? In this tab, we can select internal device, which is the internal IP that the E-Series is provided with, and you can also select the external device, which is going to be this module. And in here you have the external modules that you want to have. The customer can have 2, 3, or more external modules, and all the modules are controlled, are specified here. So you can select, and you can use all at the same time. So in this case, I'm going to select the EMITE APIX 4x4 module, which is this one, and click Connect. Okay, it's already connected. So from this button, we can configure the module. As I said at the beginning, the module can work both in station role or AP role. We are going to test right now an AP. So the role of this module is going to be station. Okay, once you configure the role, you have to specify the SSID, which the module is going to be connected to, okay, which is in this case APUT test AX. Here you have to specify the same parameters that you have configured in your AP under test. In this case, we are using band 5 GHz band. The bandwidth is 160 and the channel is 44. I'm going to check. Yeah, you can read here 44, 160 MHz bandwidth and 5 GHz for the band. Okay. And finally click Apply. I don't know if I am going too fast or too quick. Just if you have a doubt or you have a question, just let me know. Okay. Once we have the module configured, we have these other configurations. Here we can connect a channel emulator to test throughputs using different fading environments. Okay, in this case we are not going to use it, but in the future maybe this is a good topic to do another webinar, maybe, because it's very interesting. Okay, in this scenario, you have to select the scenario that is calibrated in the chamber. Right now, we have the free space scenario only calibrated. But if you put inside the chamber, for example, a phantom head, that is going to affect the environment, and the environment should be calibrated. Okay, in this case, we are going to use just free space. Okay, in here you have to specify to the software the losses of the external cables that you are going to use. Okay, these cables must be calibrated. Okay, we already did it, and here the software allows you to load the losses. And finally, in this tab, you can add the test cases that you want to test. in this case, we are going to test WLAN 802.11ax 5 GHz, channel 44, 160 bandwidth. We are going to use 3 antennas, although we can use 4, but in this example we are going to use just 3 antennas. The test mode is going to be downlink. We are not using a channel emulator, and the protocol is going to be TCP. The protocol could be UDP, or could be FTP, or it could be also video streaming. This is a new feature that we recently developed. I don't know if it's already launched. I don't know if it's released yet, but if not, it will be very recently. Okay, by double-clicking on the test case, you can configure some parameters. Here you can configure the protocol. The testing mode can be downlink or uplink. And here you can configure some TCP parameters. In this case, we are going to use 10 parameters, 10 parallel streams, and TCP window size is going to be big, and the buffer length is going to be this. Here you can configure the movement of the steerers. You can configure in stepways, single point. That means that the steerers are not going to be moving at all. Or you can choose continuous, okay, which is the mode that we are going to use in this example. In measurement, you are going to configure the behavior of the internal attenuators that we have. Okay, in this tab you can configure how the path loss is going to change during the measurement. In this example, we are only focused on maximum throughput, so we just configured a 50 dB attenuation because it's the minimum path loss that our system has right now at this frequency. Okay, so we are not going to see the throughput curve going down. We are going to see just a regular curve during the whole measurement. And here you can configure the time. It's going to be 90 seconds. And here you can activate the traffic monitor. Okay, the traffic monitor is going to be reporting important information during the test, such as the MCS, the modulation code schemes, both for uplink and downlink, etc. So a lot of information that is very useful to keeping track the progress of the measurement. And finally, here you can configure your path phase criteria. In this occasion, we are not going to use it. Okay, just click apply. And in here, in the APUT tab, you have to check connection between the control PC, where is the software running, and the other PC. So here you have to specify the AP here. All right? And just check connection. Okay? You see this green tick. It's telling you that connection has been successful. And click run. let's close the chamber door and click yes. Okay, here you can see the throughput that we are achieving right now. It's almost 1 gigabyte per second throughput. And probably you have heard that Wi-Fi X can achieve like 10 gigabytes per second. But in this environment that we have right now, that is not possible because the AP inside has the Ethernet interface of the AP is limited to 1 gigabyte per second. So that's our limitation. We cannot go further than 1 gigabyte per second. But this is what we are getting, like 949 megabytes per second, which is really good. And during measurements, here you can check here the modulation code schemes, both for uplink and downlink. You can check also the RSSI value, the signal noise ratio in real time, etc. In the summary, you can take a look at the configuration parameters. So in this point, I would like to ask you if you have any question or you have any doubts, any comments, just please let me know. Does anybody have a question or something or a doubt? Okay, if not, I'm going to continue. So let's wait for the measurement to finish so that I can show you the measurement report file. This webinar is going to be recorded, and I think it will be available for everyone online, maybe. So here, I'm going to type the model. It is an ASUS T8U or with machine. Okay, let's take a look at the results. Go on, second. This is, yeah. Okay, here you can see what's been measured. Here you have the information of the AP under test. This is the information of This is the information of the module. And finally, you can read here the throughput that it's being measured. Okay, if you don't have questions, at the end of the webinar, we have some question and answer session, so we can help you in some doubts if you have. Anyway, I think one of my mates is already online here, and he can give you some information through the chat that it's behind Adobe Connect. So now let's do the same test, but in this occasion I'm going to use an smartphone, okay? The connection setup is very simple, but I need to disconnect the throughput, the AP, which is inside. So one moment, I'm going to do it. Okay. Just remove this. And now I'm going to configure a new measurement, but for a smartphone testing, you need to change the row of the module into AP row. So let's do that. Okay, so I'm going to change this into AP. We have to select DHCP and click apply. I think we are ready now. Okay. Wait. All right. Configure 5 GHz, 36 channel, 160 bandwidth. Apply. Okay, the DHCP protocol must be activated. It says it is activated, but sometimes we have experienced that no matter what you put there, the external AP, it's not going to be used in DHCP unless you disconnect it, switch it off, and switch it on again. So let's try to connect the device and see what happens. So I'm going to use TCP downlink mode. Here I'm going to specify 10 pilot streams. Apply. And here I'm going to connect the device to the network. If the device doesn't get connected right away, probably I need to power cycle the module. Let's see. Just look for the network, which is ASUS test AX. Or you can try to put an static IP. Let's try. Let's wait. I think it's already connected. So at the same way we did with the computer, we need to do it now with the device. We need to open the MIMO client for Android in this occasion. We need to take note of the IP that the client is reporting. In this occasion is 10.10.10.33. Okay, and place it on the turntable using a proper holder, and that's it. Okay, let's check the connection here. Here you have to put the client IP address, which is 10.10.10.30.33, and set connection. Okay, we are ready, and just click Run. Okay, this computer is not needed anymore. Okay, and again, we are measuring, in this occasion, we are measuring a little bit lower than testing AP. To get this value, this curve higher, you need to fine-tune the TCP parameters, the TCP window size and the buffer length properly. And in doing so, you have to know very good the chipset architecture of the device under test. Okay, so it's a back and forth process. You have to try different parameters to get the highest curve possible. In this occasion, we are getting a little bit around 1 gigabyte. Sorry. Okay, so as you can see, this module can do two functionalities at the same time. In the past, we have offered these two functionalities separately. We offered to the customers external IPs and also a station, but separately, in separate boxes. Now this module can combine the two functionalities in just one box. And this box, honestly, is suitable for all the series that we have in the market, especially for the E series and the I series, of course. And it's installed very quickly, externally, and controlled by the software, so it's not difficult to install this in a customer that we already might have. Okay, let's wait for the car to stop and take a look at the report. But in essence, this is the idea of the webinar, to show you the latest implementations that we have done here in EMITE, so that you can have a better knowledge of what we develop here. And I think we are going to do more demonstrations in the future. So I think it's very useful doing webinars, so that you can fully know what we do here. For sure, in the past we will be doing a lot more. I think somebody is asking something through the chat. He's asking about the video streaming feature. I think the video streaming feature is not available yet for Android devices. I think it's only at the moment available for Windows. But in the future, we will be offering the video streaming for all platforms, not only Windows, but Android, Tizen, Mac, iOS, etc. Okay, in this test, as you can see, we have configured different path losses, and so we will see how the throughput value is going to be decreased at any of these path losses. So in here you can see the whole curve going down. So far, we only calculate or measured 2 points, the 52 path loss and 57. Now we are with the 62. But as you can see, we are getting 625 megabits per second, which is a little bit lower than 644, which is the idea behind attenuators. So yeah, as you can see, the curve is going down very slowly, but this value is actually lower than this, and this is lower than this, so this is okay. So nobody of you have questions. Okay, I'm willing you have some questions so I can help you. Yeah, in this occasion you cannot see the traffic monitor because I forgot to activate it. Yeah, you can see here the traffic. Oh, the traffic monitor is on. Can see it. Oh yeah, you can see it here. Sorry, yes. Yeah, you can see that as the measurement goes, the RSSI is getting lower and the signal noise rate is getting lower, and the modulations are getting also lower. Okay, we have another feature, which is the DUT monitor. The DUT monitor reports the battery level and the temperature of the device under test. Okay, so you can see what was the temperature at any moment during a measurement. Yeah, you can see the curve, how it's going down as the path loss is higher. As you can, if you watch the results, I think I can give you a little bit of information on the chamber. Okay, this is the front panel. Okay, here you connect the ports for active MIMO measurement mode. Here you connect the Wi-Fi port, and here you have the RX port for calibration. And these are two auxiliary ports. Okay, the chamber has an auxiliary antenna, which it can be used for uplink. And we also have the RX port, auxiliary RX port here, okay, which is used for passive measurement. I don't know if I cannot reach. Sorry, the cable is not long enough. Okay. Okay, we have just finished with this measurement. Let's take a look at the result report files. All right. Traffic. All right, let's take a look at the results. Okay, here we have the device information, the information of the module. We have here the summary. In this case, we have just tested one test, but we could have tested like 1,000 tests if you want, as long as the battery of the device is okay. And here you can see the throughput at any path loss value, and you can see the physical throughput. Okay, and the results, as you can see, it can be saved in HTML and TXT file or Excel file. Let's open Excel and see. See here, you can see a little bit more detailed information. Here you have the RSSI as well. And here you have all the partial measurements, all the raw data. Okay, here you can see all the modulation code scheme at any time. Okay, you can see here that when the path loss is low, the DUT is managing MCS, higher MCS. In this occasion, we are using MCS 8 plus MIMO, and as the path loss goes up, the communication use the lower modulation schemes, like MCS 4, MCS 5. And here you can see the RSSI. And finally, the average throughput and the average RSSI. All right, I think this is it. I think this is it. This being the purpose of the webinar. We have introduced to you the new external module that can do both AP testing, and it can work also as an external AP. So two functionalities in just one box, and this box is suitable for all the series that we have in the market, especially the E series and the IE series. And that's it. I think we are almost done. If you have any comments, any doubts, please let me know now, or we of course are in contact by email. This webinar is going to be available. I don't know if it's going to be uploaded on the website, or I don't know if it's going to be available on YouTube, or maybe just If you wanted to have it, we will send it to you, the recording of the webinar. So if you don't have any question, any doubt, I think we can finish the webinar, and just thank you for you all to stay there, spending some time with EMITE. Thank you very much.